Hey there, grade 11. Hope you're ready for a long video. Today, what we're going to look at is related to chapter 8.7, where we're looking at how the cosine rule for non-90 degree triangles worked. Now, in the previous exercise, we looked at the sine rule and how that worked, and that was obviously just as difficult. And now we're going to look at the cosine rule, which I think kind of pushes the boundaries that little bit further again. But like with all maths, it can be explained. Sometimes it just has to be a little bit slower. So what I've got here is obviously a non-90 degree triangle, similar to my sine example from last video. Okay, now the first thing we're going to do is we're going to label it in a similar fashion. Now what I've done is I've labeled it as angle A, side A, C and C, B and B. You'll notice I use capitals for the angles and lowercase for the sides, and you'll notice that they all correspond. And what I mean by that is, let's get rid of that, as I quickly draw, you'll notice that A lines up with A, C lines up with C, and B lines up with B in terms of sides and angles. So it all works out that way, okay? Now, as I look at this, I'm not going to tell you what values I have at the moment, okay? We know that we need to use this formula to solve for unknown values, okay? That's obviously what the sine rule did as well. Remember, your sine rule can be used, there's a sine rule for area and a sine rule for unknown sides, okay? And you can find essentially any unknown in a triangle, and I'm not going to tell you what yet because there's no point. Now, once we've done that, what we're going to do is we're going to look at how we can possibly differentiate this triangle, and I'll show you what I mean by that. Here what I've done is I've put a perpendicular height in, okay? Now, obviously that would help us if we're trying to find area and different things like that. But it still serves a purpose in this case, and we're going to utilize this. So you can still see the A's match, the C's match, and the B matches. All I've done is I've put that perpendicular height in at a right angle. Now, going a step further, and this is where I might lose some people, so feel free to, constantly skip backwards and forwards. What we're going to do is label this bottom as something different, because you'll see up here, as I drop this perpendicular height, the C isn't impacted by this line, the A isn't impacted by this line, but look at what's happened to B. Now, it hasn't been split down the middle, okay, and oftentimes it won't be split down the middle. It's split into two new lines. So what we're going to do is we're going to label this first line as X, and this second line, which goes from, I'll get this little pen out, we'll get a highlighter this time, use yellow. So this line obviously goes across here. That's your b minus x. And this is going to be just your x value. Okay? X is just a placeholder that we're using. All right? So, and obviously the whole distance is just x. So, taking it a step further, now that I've set some parameters for this, we've actually got another line in this triangle here. All right, you can call that whatever you want, but I believe we've called it, H. This we're going to define as H for the purpose of our video. So you can see here what I have is I've actually got two right angle triangles. I haven't substituted anything in yet, okay? I haven't told you any values. We don't need that. What we're going to do is we're now going to go and look at how we prove the cosine rule for this type of triangle, okay? Now, the very first thing we're going to do is we're going to look at these two right angle triangles, okay? And you'll see they've got C, X, H, A, H, and then B minus X. What do they share in common? And what they share in common is that H. Now, let's think for a second and think about how we could find that H. One method that jumps out at me straight away is Pythagoras' theorem. Now, going back all the way up to this one, okay, we couldn't use any form of Pythagoras here because there was no right angle, okay? This corner up here is not a right angle. It is not labeled as such, okay? But now that we're down back to this one, you'll see we have two right angle triangles. So the very first thing I want to do, I'm just going to quickly insert an equation here, is let's look at how we can use Pythagoras here. So the triangle on the left, little c, so c squared in this case, what is that going to be equal to? Well, wouldn't that just be equal to h squared plus x squared? Okay? There's my first bit of Pythagoras I can use, okay? So all I'm saying is that this pink line c would be equal to h squared plus x squared Pretty straightforward. Now, going over to the other side, and based on how I've labelled this triangle, okay, there's nothing special about it. This could have been A or B, all right, but as long as you get the matching pairs, it's not an issue. Now, what I've got here is I've got A, so let's change this to A to the power of 2. Okay, so in this case, how would I actually go about working out A squared? Well, it would still incorporate H squared to be equal to H squared plus, now instead of X, we've got B minus X. Now, this is the first mistake that students might make. If you write it like this, okay, you're only squaring the X. We need to square the B as well. So it's B minus X in brackets squared, okay? All pretty good so far. Now, what I'm going to do is I'm going to take this equation. I hope this works. Yep, awesome. We're going to call this something a little different. Okay? Another way that we could write this equation, as you're about to see, is A squared minus B minus X to the power of 2 would just equal H squared. All I've done is I've moved what I'm highlighting now. I moved that to the other side and made it a minus. Now, I'm just going to backspace that now. Now, the purpose of that, and up here I'm also going to do something similar, okay? Instead of c squared equals h squared plus x squared, let's rewrite this as c squared minus x squared is now just going to be equal to h squared. Now, let me just show you the purpose of that. Get my highlighter again. Notice, okay, I now have h squared and h squared. What I'm going to do now is I'm actually going to be combining these two equations. Sorry, use black. I'm going to be combining those two equations, okay? And I'm going to show you how. All right, let's get rid of that. I'll just erase it first, okay? So how I'm going to do that is as follows, okay? So a squared, whoop, that's capital, didn't copy the formula. So in this case, a to the power of 2, a squared, minus b minus x squared is equal to, now we know it's equal to h, or h squared. Instead of writing h squared, we're going to write this h squared, because remember, it is a common side. We can do that. C to the power of 2 minus x to the power of 2, or x squared. All right, and this is what we end up with. Now, what I'm going to go about doing now is just expand this out a little bit and see what we can end up with, okay? Now, the first thing I'm going to do is I'm going to expand this bracket here, okay? Now, keep in mind, I know the minus is still there. We're going to come back and deal with that in a moment. So if I was to expand this equation out, let me show you how it would end up looking, okay? Going to need two brackets in this case. B minus x times b minus x, close bracket. So all I've done, the minus is still there. That hasn't disappeared. Instead of writing b minus x squared, I've just done b minus x times b minus x. Okay? Now, copying it down, what we're going to do is this bracket is still technically going to be there. Okay, but what we're going to go about doing now is solving, or not solving, sorry, simplifying the b minus x times b minus x. Okay, using your FOIL method, that's your first inside, outside, last side. B times b is b squared. B times minus x is minus bx. Negative x times b is minus xb, or minus bx, the same thing. So already we can see a common term here that we can simplify in a minute. Minus x times minus x is actually going to be plus x to the power of 2. Now, from there, what I'm going to do is simplify inside that bracket. Okay, so if I've got minus bx, that's just going to be minus 2bx. Okay, hopefully that's not too kind of confronting for you, but that's just expanding two brackets, pretty easy. What I'm going to do for my next step, Okay, see this minus out the front here. That's equivalent to -1 times everything in the bracket. So what I'm going to do is expand that bracket out. It's going to become -1 times b squared is minus b squared. -1 times -2bx is going to be plus 2bx. And then -1 times positive x squared is going to give me minus x squared. Now what I've done is I've expanded that bracket. I can get rid of it. Okay? From there, copying our next line of working down, what I'm going to try and do is start to get some things on their own. Now, what I might do is I might move everything here over to the other side. Now, some of you might have looked at this and realized, well, hang on, we could have just moved this whole bracket to the other side and made it a positive. Absolutely, you could have, okay? Same result, all right? But I just wanted to show that expansion as well, because there's actually a lot of different ways that you can deviate from this point to end up with the same answer. So just to clarify, all I'm doing is moving what I've just highlighted to the other side. Okay, so I'll backspace them. Going over the other side, minus b squared would become plus b squared. Sorry, not in the equation. Plus b squared. Okay, next up, plus 2bx would be minus 2bx. Okay, and then finally, I've got minus x squared. Okay, that's going to become plus x squared. Now, as I look at this equation, okay, I'm just going to get my highlighter out again. This time I might use blue just to make it a little bit clearer. Here we go. The first thing I notice is I've got minus x squared and plus x squared. They are like terms that are actually going to cancel. So we're going to cancel those out now. Copying my next line down, this is what I end up with. Negative x squared plus x squared is 0, so they can just disappear. What I'm left with is a squared equals c squared plus b squared minus 2bx. Okay? Now, I just want to stop for a moment and I want to talk about this. Okay? As we compare it to the triangle up here, all right, little a, little c, and little b, okay, they're all labeled sides for this triangle. Okay, 2 is a constant. The only unusual side here, grade 11, is this x. It's not something we're typically given or possibly asked to find out in a question like this. Okay, so what I'm going to do is I'm going to focus on this x and think about what is another way that I could express this x. Okay, and how I'm going to do it is I'm actually going to look at up here. I'll just quickly get my highlighter out again. What we're going to do is we're going to look at this triangle, okay, just to specify it for you. Now, when I look at this triangle, all right, I'm going to look at how we could possibly find x. Now, remember, we now have a 90-degree triangle here. So the whole purpose of this next part is going to be finding an x value. Okay, now keep in mind, we're just working with pronumerals here, okay? Nothing new and out of the ordinary. So as I look at this triangle, okay, I realize that I can actually go about using trigonometry here. Now, I've got C, X, H, A. What are we ultimately trying to find? We're ultimately trying to find X. Is that my adjacent or is that my opposite? It's obviously not the hypotenuse. Well, it would be the adjacent because we're working with an angle A here, okay? It could be one of the things that we're given. Okay, so we've got the adjacent and hypotenuse. What trig identity uses the adjacent and hypotenuse? Well, obviously, cosine. And now we're starting to see how it's called the cosine rule. So, inserting my equation again. All right, and I know I might run over the page, so what I might do is just start this on the other page. We're going to copy this image down, and I'm actually going to put it above here. Okay, we'll crop it down so we don't get too confused. Okay, so now we know that we're just working with this triangle here. So we already established its cosine of theta is going to be equal to the adjacent side over the hypotenuse. Okay, from there we're going to substitute the values, or in this case the pronumerals, that we're given. So in this case, Going back, we know that the theta is actually labelled as capital A. We know that the c value is our hypotenuse. Notice it's lowercase c. And in this case, the adjacent is our x value. So we end up with cosine of A is equal to x over c. Now, from there, I'm going to rearrange it into the following. Moving the c to the other side, okay, I'll just be left with x. It's going to be c times cosine of A is equal to x. Now, what I'm now going to do is, and I'll put a little heading here, we're going back to our previous formula, that is this one. Again, just going to get my highlighter out and just highlight a bit of useful information. What we now have, oh, I just realised, sorry. Keep making little mistakes. That should be C. My apologies. The C comes around the other side. C times cosine of A equals X. Sorry about that. Okay, now going back here. The two X's there, and I might just use a bit of a smaller highlighter there. The X here is going to be the same as the X here, isn't it? So instead of writing X, what I'm going to end up doing is expressing X as C times cosine of A, okay? So, expressing that, let me just erase this for a second. Okay, so just copying and pasting this down. Instead of writing X, remember what I said, we're going to write C times cosine of A, okay? And notice what we have here is we now have a formula. Now, let's think about how many different unknowns we have here. And I might bust out the highlighter again while we think about this, okay? Because what this is going to help us kind of establish is how much information we need to be able to solve for a question. So I'm going to get the highlighter out and let's count the different unknowns. First of all, A squared. That only, or a, little a in this case, only appears once. Next, I've got C, and that appears twice. Okay. Next up, I've got a B, and that appears twice. Now, I do have one more unknown, and that's right here. That is my A value. So when we deal with the cosine formula, we have a grand total of 4 values within the formula. Now, with any formula, to be able to solve for an unknown, you need to know all but one of those values. Okay, so what that means, I'm just going to copy and paste this triangle down. Let's copy and paste this one. Computer's just going a bit laggy, but that's okay. So going back and comparing it here, okay, if we have A, C, B, and capital A, all right, so just highlight those, erase that now. We've got A, why is that not highlighting? Oh, it's just really tiny. Sorry, make it a bit bigger. We've got A here, B, and C. And then we've also got capital A. Now, what this tells me is if I know all 3 sides of a triangle, similar to Heron's, I can actually find an unknown angle. Okay? On top of that, looking at this here, I can also, in some cases, use it to find sides. Now, because I've got here C squared and C and B squared and B, okay, I would need to know B and C. Okay, I have to know those. In general maths, we don't look at any kind of quadratics where we could potentially solve for, say, squared values in this circumstance, okay? It's a bit too complicated. So ultimately, what I'm trying to tell you, just quickly erase these, is if we knew all 3 sides, we could actually find the unknown angle. The other scenario is when we have 2 sides and the connecting angle, we can find the corresponding side, okay? And what I mean by that is we can find this over here in terms of an unknown. Now, let's have a look at this formula and let's see if there's a particular pattern that we can observe with this. Okay? So what I mean by that is, I'm going to take this formula and we're going to see if there's a pattern. So straight away, we've got a squared equals c squared plus b squared minus 2bc cosine of a. You'll notice that these two squared values here correlate here. And the angle matches the value out here. So if I was to copy and paste this down, let's write it another couple of ways. If I made this b squared, the first thing I'd need to do is realize, okay, if I've got b squared there, these values have to be a and c. Because remember, as I spoke about with labeling the triangle earlier, because we are no longer dealing with a right angle triangle, get yourself out of that mindset that C has to represent the hypotenuse. In this case, A, B, and C can be labeled however you want in a non-90 degree triangle. A could be the longest side, B could be the longest side, C could be the longest side. Doesn't matter. So if I've got b squared equals a squared plus b squared, okay, remember these values matched here, so that's going to be minus 2 times AC. Now, instead of using angle A, which would have to match the one here, we would have to do angle B. Notice I've used capital B. Now, let's see if that holds true for that pattern that I spoke about earlier. Okay, and that pattern, if I can scroll here, if I can scroll about here, no, okay, it's not going to work. I'll have to quickly redo it. Remember what I said. Okay, we needed the two sides, so in this case it was C and B, and the joining angle for them. So here, if we're trying to find side B, okay, we have to know, in this case, side, make that a bit bigger, side C, side A, and angle B, and that's what we do. See, notice it's the joining angle here. Now, let's talk about the final one. So we've done AB, now let's do C. Well, that's just going to be a squared plus b squared minus 2ab cosine of c. And these are the three different iterations of our cosine formula and how it's actually generated. Okay, I know it was a lot to kind of go through. The cosine rule does have a lot of algebra, a lot of proofs in there. I'm hoping that this video has helped you see the different steps you need to take in order to prove that formula. Now, you won't be asked to prove that on the exam or anything like that. But I know personally I work a lot better when I can actually see where a formula comes from. We're not just going to throw you these formulas here and say, hey, just remember them. I like exploring that area of mathematics. Okay? So hopefully this video has helped you. Okay? This was just an introduction. We haven't started any of those values yet. That's what we're going to do in the next video in 8.7. So once again, grade 11, thank you very much for watching.